Day 3, problem 1. A ladder is leaning against a wall. Its base is 5 feet from the wall and it reaches 12 feet up the wall. Question A, sketch a diagram. And then in question B, we're told use the Pythagorean theorem to find the length of that ladder. So we need a drawing of this situation. If we just draw a vertical line, that could represent a wall. And then crossed here, horizontal line, that is the floor, the ground. And then a ladder leaning against a wall. How about something diagonal like this? And so here is my ladder, and let's say these are the rungs of the ladder. I'm not a great artist, but I'm trying to create something on my paper that looks like there's a wall and a floor and a ladder leaning against that wall. Now we can do some labeling of measurements on this picture. It says the base is 5 feet from the wall. So where the wall meets the floor is a right angle, a 90-degree angle, and it's from the ladder to the wall, that is the 5 feet. And so there's where the 5 feet goes. And we're told that the ladder reaches 12 feet up the wall. So this spot here where the ladder's touching the wall is 12 feet from the floor. So it's this side of that triangle-shaped drawing that is the 12 feet. And what we're asked to figure out is how long's the ladder? How long is this side right here of this triangle shape? We don't know how long that is, but in part B, we're given a hint of how we can find that. Use the Pythagorean theorem. So this is our drawing for part A. Let's tackle part B. Use the Pythagorean theorem. The Pythagorean theorem is a formula from geometry class that refers to a relationship between the three sides of all right triangles. And when I drew this picture, I see that it has the shape of a right triangle. So I look at this and not only do I see, well, yeah, it's a ladder and it's supposed to be a wall and so on, but in a math context, I see a right triangle. Okay? And what the Pythagorean theorem says is that the shortest leg of a right triangle squared plus the next leg of the right triangle squared will equal to the length of its hypotenuse squared. In symbols, that's shown as a squared plus b squared is equal to c squared, where the letter A is representing the shortest leg of the triangle. In our picture, that is the side of the triangle with the 5 on it. And so we can substitute a 5 for the letter A. The symbol B in the Pythagorean theorem means the other leg of the right triangle. That's this side here that has 12 feet on it. And so 12 can be substitute in for B. The letter C in the Pythagorean theorem represents the hypotenuse of the right triangle. The hypotenuse of the right triangle will always be the longest of the three sides. It will always be located opposite from the 90-degree angle. It's this one here that looks diagonal to us. That's the one that is the letter C in the Pythagorean theorem. And we don't know how long that is. And so since it's the letter C in the formula, it makes sense to put a letter C in our drawing to represent that side. So we're going to use the variable C to represent this side of the triangle that we don't know how long it is. And so in our formula, it's the variable C. Now we have an equation, 5 squared plus 12 squared equals C squared. We're going to solve that equation for C. Okay? So here's the equal symbol, and a line coming down to help keep the left side of the equation separated from the right side of the equation. And let's solve this. 5 squared is 25. 12 squared, which means 12 times 12, that's 144. And that is equal to C squared. Okay. Now on the left side of the equation, 25 plus 144. That can be done. That makes 169. And that is equal to c squared. Now we want to solve this equation for c. We want to get the variable c alone, and that means we need to remove its exponent of 2. So we need to do some kind of math step that's going to remove squaring, and that is called square root. So square root the left side of the equation, and square root the right side of the equation. The square root of c to the second power is c, because c times c is how you get c to the second power. The square root of 169 is 13, because 13 times 13 is how you get 169. And so we have that 13 is equal to c. In our drawing, the letter c was written on this side of the triangle, which is representing the ladder, and so that is the length of the ladder. So we figured out that the ladder was 13 feet long. Now day 3, problem 2. You charge $1,200 on a credit card that charges 14% interest, compounded monthly. If you make no payments on the card for 6 months, then how much money do you owe the credit card company? And we're given a reminder here of what math formula we need to use for this situation that involves compounded interest. So this math formula is what we're going to use. In the formula, letter A is the amount of money. That's what we're asked to figure out. How much money do we owe? So we're going to find an answer for the letter A. The letter P represents the principal. Another word for principal is initial or starting. It's, in this case, how much money did we start by putting on that credit card? That's the $1,200. That's going to be the letter P. The letter R is our interest rate in decimal form. The letter N is the number of compounding points per year, or another way to say that is the number of times per year that the interest is compounded. It means the number of times per year that the credit card company is going to calculate your additional interest you owe them because you borrowed from them. And the letter T is representing time in years. Okay? So let's start by copying that math formula down. A equals P times, and then in parentheses, 1 plus R divided by N, and close up those parentheses, and then the exponent on there is N times T. Okay? We're going to solve this for A. What's A equal? Okay? And the way you use any math formula is you replace the variables within the formula with numbers that you know. And then the one letter of the alphabet that's left over, you'll be able to find that answer. So the letter P, the principal, you charged $1,200 to begin with. That's the letter P. So fill in 1,200. Okay. 1 plus. Now the letter R, that is interest rate in decimal form. So when it says that the credit card has a 14% interest rate, sometimes that's called APR, a 14% APR, annual percent rate. What is 14% written as a decimal number? Well, if we move the dot 2 spots to the left, that's 0.14. 0.14 is the decimal for 14%. Okay? And now the letter N, the number of compounding points per year. So how many times in a year is the interest compounded or calculated? It says it's compounded monthly. So the word monthly, how many times per year does that mean? 12 times per year. Now up here in the exponent, the letter N appears again. That's 12. Times. The letter T is the time in years. How much time is going by that we are owing the credit card company this money, and all during this time, they keep compounding our interest or adding to our interest that we owe them every month. It says that we don't pay them for 6 months. So the time that goes by is 6 months. But we're not going to just put a 6 here because the letter T is time in years. So we need to put in a number that's equivalent to 6 months, but it's a number that's measured in years. So 6 months is the same as how many years? 6 months is half of a year. And so I'm going to put in the number 1/2 for T. You could put in the decimal 0.5. That's the same thing as 1/2. So here is what our formula looks like with all values filled in except for the letter A. If we now find this answer, that will be the amount we owe the credit card company after 6 months. Okay. Well, we can do a little bit of work on this to make it simpler looking, but when it really comes down to finding the actual amount of money because of the decimals involved, because of the division by a 2-digit number, the size of the number, it would definitely make sense to use a calculator to find the final answer. But the one thing that we could do without a calculator, just to make it a little easier to type in, is to figure out what the exponent is up here. 12 times 1/2. That's 6. This is going to be a lot easier to type in the calculator and a lot less risky of typing the wrong button on the calculator than if you tried to type this in and maybe messed up that last little bit, maybe put the times 1/2 not in the exponent, but maybe accidentally down like on the main line of the problem. This is just prone to errors in calculator. Okay, so this is about as far as we can get without a calculator, and then with a calculator we can find that value. Let's do that. Okay, so here is the calculator, and we need to type in this expression. So 1200 parenthesis 1 plus, and then 0.14 divide 12, close up the parenthesis, and now we want that exponent of 6. On this kind of calculator, the exponent key is the arrow key that's right under the clear button, and then the 6. And so this expression that you see on the screen of the calculator is the same thing as what's written on here on the paper. Hitting enter, we have an answer of 1286.4884 and so on. Remember that we're working in the context of money. So if you're working with money, you're going to do a little bit of rounding. Okay? Remember, we have dollars and cents. So this spot here, we're going to round this. To round, you look at the next digit over. Is that 5 or higher? And it is. And so that means you round this to a 9. So this is $1,286.49. If we borrow $1,200 and we don't pay that back at all, as time's going by, we continue to owe more and more money to the credit card company. After 6 months of time, we owe them $1,286.49. The $1,200 was what we borrowed from them originally that we have to pay back. That's called the principal. And then the $86.49 is the extra money that they're charging us as time's going by and we continue to not pay them back. And that extra amount of money is called interest. And so this amount right here is the answer to this question.